Hello children, welcome back to my channel. I am now dealing with second chapter SSC Physics, chemical equations. In that chemical equations, 2 marks, 4 marks, 6 marks I have completed. Now I am doing objectives. So the first bit is the number of oxygen atoms took part in the following chemical reaction. That is, the reaction is two copper sulfate molecules are reacting with three oxygen molecules to give rise to two molecules of copper oxide and two sulfur dioxide. So, how many oxygen molecules are participating here? 3 into 2, 6 oxygen atoms are participating here. So, that is the question, children. You have answered. Next, second. How many moles of oxygen will be required to burn 20 moles of hydrogen according to the following equation? See, 2 moles of hydrogen is reacting with 1 mole of oxygen to give rise to 2 moles of water. So, 20 moles means 20 divided by 2, that is 10 moles. 20 moles of hydrogen divided by 2 moles. 2 moles of oxygen. How many moles of oxygen will be required? 20 moles of hydrogen to burn 20 moles. See, to burn 2 moles, 1 mole is required. To burn 20 moles, how many moles are required? So, 20 to burn 20 moles, 20 into 1 by 2, 20 by 2, that is 10 moles. Which of the following is a balanced equation? So you can see here children, one magnesium on left side, one magnesium, two oxygens are here in reactants, one oxygen. So it is not balanced. Carbon 1 here, but oxygens 2 are here, 1 is here, it is not balanced. Hydrogens 2, oxygens 2, but here oxygen is only 1, it is also not balanced. Calcium 1 molecule, 1 atom, here calcium 1 atom, carbon 1, here carbon 1, oxygens 3, here also oxygens 2 plus 1, 3. So this fourth one is a balanced equation. The balanced chemical equation of sunlight. Sunlight equation is nothing but this is given as silver chloride giving rise to silver plus chlorine. In the presence of sunlight, silver chloride is it is decomposing into silver and chlorine. So if you want to write a balanced equation, so silver chloride, silver and chlorine, chlorines 2 are there, so here also you have to take 2. When you take 2 here, silver is 2 here and here is only 1, so you have to take 2 more here. So this is a balanced equation. Fifth one, the balanced chemical reaction in the following. What is the balanced chemical reaction? So here also sodium 1, oxygen 1, but oxygen 2 are there. Hydrogen 1 is there, here they are 2. So it's not a balanced one. 2 sodium, 2 oxygens, 2 hydrogens, 1 zinc and 1 zinc. So this is the balanced equation. Second one is the balanced equation. C2H6 plus chlorine gives A plus HCl. What is this A? A is nothing but C2H4Cl2. One hydrogen will go to one chlorine here. This chlorine becomes 2, bifurcates into 2. One chlorine atom takes hydrogen here, it forms HCl, and another chlorine atom will be added here. That is why one hydrogen will be reduced, one chlorine will be increased. C2H4Cl2 is the answer for it. The reaction that takes place when quicklime is added to water is, that is, heat liberation reaction. That means what? Exothermic reaction has taken place. Now, take the question, children. Number of moles of oxygen needed to produce 4 moles of water on reacting with 4 moles of hydrogen gas. This is the question. So this is the question. That is, see, the reaction is 2H2 plus water gives 2H2O. That means what here, children? 2 moles of water. Water on balancing 2 moles are forming. It needs only 1 mole of oxygen. Now 4 moles of water needs 4 into 1 by 2, 4 by 2, that is 2 moles is the answer, children. Now, ninth one. Burning of magnesium crackers is a reaction of oxidation. Of course, the reaction burning of crackers is an oxidation reaction. The process of preparing slaked lime by adding water to quick lime is this type of chemical reaction. Which type of chemical reaction? These all are exothermic reactions. Means what? If you just take slaked lime and pour water to it, it gives it appears as if water is boiling without producing or without providing any flame to it. It appears as if it is boiling. The reason is it is an exothermic chemical reaction. It is liberating heat. Next, zinc plus 2HCl gives zinc chloride plus H2 is an example for. Let us see, zinc is taking chlorine and hydrogen got separated. That means what? It is called displacement reaction, chemical displacement. If the gas liberated in an experiment allows the burning splinter to continue burning more brightly in the presence of the gas, then the gas is definitely it is oxygen, testing for oxygen. If you keep a burning splinter, if you burn vigorously, if it burns vigorously, it is the released gas is oxygen. If the flame is put off with a pops on, that is hydrogen. Those are the characteristics of oxygen and hydrogen. 30th one, which of the following is not a chemical, a balanced chemical equation? Here 1 zinc, 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen. So it's a balanced one. Calcium, calcium, carbon, carbon, oxygen 3, oxygen 3. Sodium 2, here sodium 1. So this is not a balanced equation. Third one, fourth one, of course, it is. Now, at STP, standard temperature and pressure, how many liters of hydrogen gas evolve when 4 moles of hydrochloric acid used in the following chemical equation? See children, one volume of 1 mole of hydrogen at hydrogen gas at standard temperature and pressure occupies 22.4 liters. Now, in this balanced chemical equation, zinc plus HCl gives zinc chloride and hydrogen. Here balancing, you have got 2 here, hydrogen to balance. Now, here, how many, the question is, at STP, how many liters of hydrogen gas evolved? See here children, hydrogen atoms are 2 evolved here. So, 2 into 1 atom of hydrogen, it takes 22.4 liters, 1 mole of volume, 1 mole of hydrogen gas at standard temperature is 22.4 liters. Here you have got 2 moles. So here the reaction is 2 into 22.4, that is 44.8 liters. Okay. How many liters of hydrogen gas evolve when 4 moles of hydrogen chloride is used? Here actually in this chemical equation, 2 moles are used to get 1 mole of water. Here when it is doubled, here also it should be doubled. 4 moles of hydrogen chloride you need is reacting means 2 moles of water, hydrogen molecules will be liberated. See, when 2 moles of hydrogen chloride is reacting, 1 mole of hydrogen gas is liberated. So, when 2 moles of HCl is used, then this is also doubled 2 moles. 1 mole is occupying 22.4 liters, it is given 2 moles means 44.8 liters. How many moles of oxygen will be required to burn 20 moles of hydrogen according to the following equation? See, 2 hydrogens plus water is giving 2H2O. So here the equation is 1 mole of oxygen burns 2 moles of hydrogen in this balanced equation. 1 mole of oxygen is burning 2 moles of hydrogen. Now, how many moles of hydrogen is needed? 20 moles of hydrogen. Needs how many moles of oxygen? 20 by 2, that is 10 moles, is the answer, children. So, with this objective part is also completed. The chapter is completed, children. In the next class, I will be dealing with the next subject, next topic, new topic.